should be
I'll be right back.
almost live now. At least we're live actually. So I mean we're live as far as the music on hold. So we'll get started in a second. Take it away.
Get the show on the road. Hello, everybody. Thank you for joining us. This is kind of like a weird meetup, only because it involves so many groups. It was announced with DC 210. It was announced with Red Team Village, and it was also announced with Texas Cyber Summit and Grey Hat. So a lot of people on this call are involved in all of those events. So with me, I have Omar Santos from the Red Team Village, and I have Jeff Carroll, who's going to be teaching the class on IPv6. And I'll introduce Jeff here shortly after that. We're going to do some announcements real quick. I wanted to share my screen so you guys can see some of the stuff that we have going on. So from the Red Team Village perspective, we have NAHAMCon. It is on Sunday. A whole bunch of really great speakers that Red Team Village is putting on. And Omar, you want to go ahead and talk about those events real quick? Omar? I can't hear you. No audio.
Of course, I'm on mute, double muted. But what I was, trying to attempt to say is that we have a lot of content coming in the next few months, and as a matter of fact, in the next couple of days, starting with that NAHAMCon, as you mentioned, that's on Sunday. And we're going to have a series of a combination of workshops in the Red Team Village and presentations. The schedule, if you click on the RTV schedule during NAHAMCon, there's the first button there. And I'm looking at another window, so my apologies. I know I should be looking at the camera. But we have several workshops, some that are 3 hours long, some that are 2 hours long, some that are 1. And the speakers are a little bit, first of all, thank you to the speakers. Second one, they're a little bit brave because they're going to be doing this workshop to thousands of people live on Twitch and YouTube at the same time. So you do not have to register. That's one of the questions that I always get. You do have to register for these trainings. And no, they're going to be completely free. And there will be during NAHAMCon. Now, there's a main track that NAHAMSec, his name is Ben, he actually has been sharing. We also have a link to the website in the Red Team Village, but, please take advantage of that. This is an amazing content. They're all going to be streamed, and they're also going to be recorded. And we're probably going to restream a couple of them later as well. So that's NAHAMCon. And then we're partnering with Hacking is Not a Crime. And as a matter of fact, probably within the next day or so, we will also have the schedule for that conference, and we have an amazing lineup of speakers for that one. We have some really high-profile individuals that I'm not going to spoil it yet, but it's going to be announced again, probably by the end of tomorrow, and it's a pretty cool concept, or I won't say concept, but initiative that we have going as a partner of Hacking is Not a Crime, right? And then if you want to talk about RSA, Joseph, and what we're envisioning there.
Sure. So RSA this year is going to be virtual. Last year it was in person. They pushed it to May 17th. Normally it's in February. We're going to have probably about 5 or 6 speakers that will be giving talks. We're going to have lightning talks. We're going to have some demos of some products and some hacking techniques. And then we're also going to have some birds of a feather calls or events where you can join them and sit in on a panel of 25 or so attendees, and there'll be 5 or 6 speakers that will be talking about a specific topic, like red team tools and tactics, or platforms for doing assault, attacks, and all kinds of cool things going on at RSA. And that is, we're also going to have a CTF that's going to be it's kind of cool because it's going to be a 101 CTF. It'll be a CTF that everybody can participate in. But the team that does the CTF will be doing a walkthrough. So it's going to be a 101 walkthrough. So they're going to actually show you the actual challenge, and then they're going to talk to you about, thinking about how you should approach that challenge in the CTF. And then they're going to actually walk you through doing the challenge. And they're going to do that for a couple hours. And then on Thursday of that week, they're going to launch a professional CTF where if you feel like you've learned enough skills or you're daring enough, you can join that one and participate in much harder challenges. So that's RSA. And then Mayhem, which we held for the first time last year, was in May, and that's why we called it Mayhem. And we had a lot of a huge response from people. I think we had over 100 speakers, and we ran it for 2 days, and we ran it in multiple time zones. We had a group of people help us from another time zone in India. It was an amazing event. It's going to be even more amazing this year. And then after Mayhem, we're going to have DEF CON and Black Hat and some other events going on, but those will show up eventually. So that's Red Team Village. I don't know is there anything else you want to mention, Omar, before I switch?
Of course, you caught me off guard while I'm trying to verify that the stream is working. No, I think that you cover everything, right? So there are going to be more announcements coming up, especially whenever we get closer to DEF CON and several other, activities that we may be announcing. But as you can tell, we're back, and we're back really hard, right, with a tons of additional content. I don't know if you wanted to mention, that we're envisioning to also stream from time to time, as we are actually doing right now. Right now, it's kind of impromptu, into the fact that we didn't have a lot of advertisements for this one. But stay tuned. We're going to be also opening call for papers for these events. We're going to be opening call for workshops. We're also going to be calling a call for volunteers as well. So stay tuned. More news to come in the next few days.
Right, and like Omar mentioned, our plan is to host 4 of these a month for the next couple months. So stay tuned. Join our Discord channel, the Red Team Discord channel, or one of our other Discord channels to find out more. Another event I want to mention is the Texas Cyber Summit. It is going to be in October. It'll be partially live, and I don't know why this screen is like that. There we go. It'll be partially live, and it'll be partially virtual this year, just because of limited on-site events and social distancing and all the rest of that stuff. But we're expecting to host around 500 people in person in San Antonio, Texas in October. We already have some really great keynote speakers and a lot of training and a lot of other speakers lined up. The schedule is going to start being published shortly. Our call for papers hasn't even opened, and we already have some amazing people already lined up for the event. So that is in October. And then at the beginning of November in Orlando, Florida, is going to be the Gray Hat conference. This one's going to be quite a bit bigger. It's going to be around 1,000 people. It'll also be virtual as well, so you can attend it virtually if you don't feel like going in person. And there, again, a lot of amazing speakers. Most of the ones that you're going to see at Grey Hat have attended much bigger events, and yeah, you'll, like Omar mentioned, you'll be surprised and happily surprised as we start announcing who our keynotes are and who some of our training partners and stuff like that are. So stay tuned for that. And so without further ado, if I didn't miss anything, Omar, you're muted, but I want to see if you have anything you want to add.
I think you cover everything. So
okay. Yeah, so without further ado, I'm going to announce Jeff Carroll and introduce him. Jeff, thank you for joining us. Really appreciate you doing this class. I know there's been a huge interest from everybody in IPv6, IPv6 security, IPv6 hacking, IPv6, setting it up and, what to look for and analyzing it and all the rest of that stuff. So I'm going to let you take it from here. Hopefully you can grab the ball. I saw you disappear for a minute.
I did. I may be on that second link.
Okay, I just made that second link presenter.
Okay. And I'm starting my share.
All right, we see it. Well, we don't see it. We see you're starting it.
We see we're starting. So welcome, everybody. I can go ahead and at least talk, I guess, while we're waiting for it to come up.
Yeah, and if you want to mention how you want to handle questions and answers during the event as well, that would be good.
Sure, great. I'm okay if folks want to put questions in chat as I'm kind of going along, and I'll try to monitor it, keeping 15 screens and lots of computers here and everything else going. But if you give me for just a minute, let me get all those windows open. But if you want to ask questions as I go along, that's fine. And let's just say I will try to get to them as we go. So definitely can make this interactive, and we'll have a little bit of good time. I've got lots of things to, I would say, show. So first off, I am going to have slides. This is an online seminar, webinar session. We have to have slides. It's just the laws, right? But it's not necessarily tons of slides. But part of it is to kind of set the pace here and a little bit of understanding of IPv6 as the protocol. Maybe you are deeply familiar with it. I recognize a few of the names in our session tonight, so I know that there is quite a bit of knowledge here, as well as maybe some are not as familiar with it or haven't used it in a while. We get a lot of that. Yeah, I played with it during some certification work, but I haven't been back into it since. And so, okay, we'll work with it a little bit more. So I want to do that because I'm going to bounce around a number of different topics when I actually start my demo bit. I've got a varying amount of different things that I want to show. Right now, you see a shot of Wireshark on a static trace, and I'm going to bounce back and forth even from a little bit of my slides into this. Also, I'm going to be accessing some different systems here in my lab to show a little bit more of what's going on in this operation. From time to time, I'm going to kind of do the verbal wink, wink, nod, nod, because there would be a topic of interest from, I would say, a security viewpoint. And we'll kind of call that from a red team thinking / blue team thinking. And you'll kind of get my mode here as I get going through it, because it's interesting overall. One of the questions I typically ask in a face-to-face group, it's a little bit more challenging here, although we do have a hand up icon. If you hit down there, those double or the triple dots in the bottom bar of your WebEx screen, do we have a hand up? Oh, we don't have a hand up. Okay, I thought we might. Oh, we do have. Okay, you hit the little smiley button and there's a raised hand. So I generally ask this question: who is working actively with IPv6? Not just kind of playing with it in the lab, but running it in what I'd call a more production mode, whether it's in your home network, perhaps it's running in the office, but just kind of getting a little bit of an idea if anybody is actually running, IPv6. The general response is not much, or even to a little bit more recent time, well, I'm not sure. And it's really interesting. There was a big uptick of IPv6 traffic in the US just a little bit less than a year ago. And we believe that was because, one, the pandemic and all of the work from home operation, and a lot more people doing a lot more, I would say, internet accessing. And some folks may be getting on different providers. I know I switched last year to get more bandwidth, better bandwidth, as it were, in my own environment. And in that process, I actually gained IPv6, and that's what we saw, a lot of uptick. And we think it was because a lot of the home networks were getting it. We actually see it being lit up more and more from that perspective. So a lot of folks, even in an office and network, may have IPv6 turned on and don't know it, which is actually the general operating system platform. Is V6 is enabled. If it can be used, it will be used. If it can't be used, it of course doesn't get used. It also presents a few other interesting challenges, and probably talk just a little bit about some of those as we go through. All right, with that, let me start the slides and kind of talk to, I don't know how that got all the way up there, a little bit of what's going on. I'll give the disclaimer. I am a networking and big data instructor at Hewlett Packard Enterprise, and this presentation is not a Hewlett Packard Enterprise presentation. This is Jeff, man on the street, enjoying playing with technology. I've been working in and around IPv6, I would say consistently for about 11 years. Actually had played with it 20 years ago, but not very much. It started a lot more working in it over these, again, last 11 years. So we'll talk a little bit about it, talk a little bit about the addressing, a little bit about some of the protocol operations, how it works from also an addressing viewpoint. And part of what I want to talk and actually show is varying what I call infrastructure level applications about or how that's being used and how they can be used from IPv6. There's actually sometimes a little bit of a nuance in how you use IPv6 from an application viewpoint. And so we'll kind of see some of those. And then, of course, if you've ever seen a presentation that I've done, I always like to show the protocol at the core kind of level using Wireshark to do that. So we'll have that. So IPv6, if you're not familiar with it, it's a 128-bit address, so it's huge compared to our 32-bit address in V4. It's colon hexadecimal. I know for me, I am not a great typist, and I start working with it, and it's like colon, that's a shifted character. That takes me to, my two typing fingers to do that. And it actually will be potentially a bit of a challenge in your early V6 travels because we're so used to typing in numbers with dots. But now we got to deal with numbers and letters and colons. But after a while, it's not too bad. And in fact, about midpoint in there, you'll find yourself doing 192:168 dot, and then you go, wait a minute, that's not right. Or you'll be doing 2001 DB8 1.3 : oh wait, and you'll mix your dots and your colons. It happens, it's okay. We just kind of learn and work through it. If you've been in networking for a fair amount of time, you'll remember the days of AppleTalk protocol, IPX SPX protocol from Novell. Those were hexadecimal number-based environments as well. Basically, when we came into IPv4 in not quite 30 years ago as I would say, a standard protocol within the network, definitely started bringing itself in the early mid-90s. And then by around-ish 2000, we pretty much saw all those other protocols go away in most networks. To this say back with, we're into words again. We can do hex words, yay. And you can actually see down here, I've got this address at the very bottom, 2001 DB8 1010 6 Lab Foosball Dallas. Okay, and this is great and this is fun. And so we take that 128-bit address, we break it up into 16-bit chunks, And we typically think of those chunks as either a quibble or a hextet. Now, the hextet is the most commonly used term now. Actually, it would be a hexadectet, but that would be a little hard, especially for me. I'm in the South, and we have to add syllables to everything. So hextet's a little bit easier. This is great. It actually makes it a little bit easier to get used to this 128-bit number. That is quite often the biggest deterrent I see with folks is it's huge, it's got colons, it's got letters. Now, this is just no fun. Well, we start looking at this address, and one of the base standards about this address is that in I would say, endpoint network, whether that be like a server VLAN or a user VLAN or an application VLAN, whatever it might be, the common denominator is what we call a /64. So it's a 64-bit network prefix followed by the 64-bit interface ID, or what we may think of as a host ID. This is pretty much analogous to a /24, which is probably one of the most common size VLANs or subnets that we might have in a lot of networks. I'm not going to say it's everybody's, but most of our endpoint networks are probably a /24. And we also know within that /24 that typically the first 2 to 3 octets relate to something, a site, building, VLAN, or just a VLAN unto itself. There's something about that we recognize very quickly. We get the same operation now in this V6 network addressing because of the first 64 bits being part of the network ID. The more typical thinking or use case here is that the first somewhere between up to 48 bits are probably assigned to you. Or to an entity. You may actually get a smaller network space depending on the size of the entity. A multi-site enterprise, it's kind of like go get a /44, get a /40. If you're a multinational enterprise, you get a /32. You might even start, kind of having that look and feel of almost like a provider. And then the rest of those bits are yours for doing that same kind of thing of breaking it down to, site building network. The last 64 bits being the interface ID, this becomes a lot more of a discussion point. How that gets assigned, whether you manually assign it, whether you assign it through, say, DHCP, or whether it is assigned from an automatic operation. Now, the key is a lot of people say 64 bits for an interface ID is what? 18 billion possible host IDs. Okay, when you can wrap your mind around that, you can say that that's how many times bigger than the entire V4 space of 4.3 billion addresses. Okay, it's huge. The next place a lot of people go with that say, why in the world would I waste all those addresses for a VLAN that's going to have maybe 200 devices? Oh, wait, maybe I've got some big VLANs of 500 devices. 18 billion is wasting a bunch of addresses. Well, don't go there, okay? One, we're not really wasting. Two, the address capability, address space, the address block availability of V6 is the quote, we will never run out. It's 340 undecillion potential addresses. That's 34 with 34 zeros to the right of it, okay? Now, a lot of people still say, but no, it's don't go to the point that a 64-bit host ID is wasting addresses. Just don't worry about it. And in fact, part of the don't worry about it is that you now have such a larger address component for that host ID or the interface ID, is that it might be a slight bit of security. The key is scanning. Try to do an nmap scan of a /64 single network, all right, is one of those things that the more or less computed time is. It's going to be like 50 years. Okay, maybe not even 50 years. So if it's 20 years, there's just not a good way to scan a single V6 typical subnet. Now, What that does mean is that because it is such a big number, a lot of people are going to go to the point of, I'm just going to make life easy. I'm going to do everything like my v4 addressing. In fact, I may even embed my v4 address inside that host ID. Don't do that either, because that's what the bad folks, a red team thinking is, well, I'm going to scan a lot of known things. I'm going to scan for 4-digit hex words. I'm going to scan for : 1 through 254. I'm going to scan for 192:168:2:10. All right. I'm going to scan for those things. Well, that reduces my attack vector or my scan vectoring by a lot. So don't do that in a production. Don't put words in a production network. All right. Now, best practices of saying this, ping Facebook. I'll do that a little bit later on. Facebook puts Facebook, FACE::BOOC, in their 5th and 6th hextets. They didn't ask Jeff, but that's 32 bits that I don't have to pay attention to. The first 64 bits I can find out. So the next thing you know, I've got a lot of space that I don't have to scan for because it's fixed. So this is why perhaps a 64-bit interface ID helps keep us a little bit, I won't necessarily say safer, but it's going to be a little bit harder work than it is to scan a traditional IPv4 environment. In V6, we have some shorthand notation capability. We can concatenate down from leading zeros within a hextet, as well as groupings of zeros in a hextet, one or more groupings. So you see through that middle address, my 2nd and 3rd hextets are all zeros. My 4th hextet has a leading 0. 5th, 6th, and 7th hextets are all zeros. So option 1, I could concatenate my 2nd and 3rd hextet to a double colon. The 4th hextet dropped that leading 0, and then 0, 0, 0 in my 5th, 6th, and 7th, 5th, 6th, and 7th hextets. Or I went option 2, where I concatenated the 5th, 6th, and 7th hextets down to a double colon and all others, because you cannot put double colons twice, because you don't know how many bits are represented on each side. All right. So if you're going to use the shorthand notation, the basic rule of thumb is use the one that provides the considered most compression. All right. And that would be option 2. The other bit, do you use upper or lowercase letters? Well, the RFCs basically state use lowercase, but it is not illegal or wrong to use upper. And in fact, some vendors will convert your entered lowercase to uppers. Some will convert your entered upper into lowers, and some will take it as is. So the bottom line is we kind of look at this and say, as a best practice, you can use compression and kind of should use the one that gives you the most. Just the key remembering is don't try double colons. I actually, in all of my travels, have not found any OS of any platform that would allow me to do that double colon. We look at the different address types in V6, and there's just this one real big difference. There is no broadcast type traffic in IPv6. It's referred to as an on-link multicast. All right, so anything we think of in broadcast type traffic mode in V4, on-link multicast, it's got a multicast prefix. That's your big difference. So if you're looking for that quote broadcast looking traffic, you're okay, it's just going to be a little bit different, but it's a little bit thing of information to know. When we look at our types of addresses, we have the still basic 3. They're referred to slightly different, perhaps, in that I'm going to start with that link local address. We've had a link local address in a V4 world, as I'll call it a basic standard, since about Windows 7, perhaps, maybe a little bit more before Windows 7. Actually, I'm thinking maybe Windows 98, but it was basically that built in, if you're not statically assigning and you're not DHCPing, a self-derived 169.254/16 v4 address. And that was basically so you could do workgroup networking. And it was so well liked that basically, a technology level that everybody, most from the vendor viewpoint, client and server OS, pretty much implemented. We know this as the HIPAA address. However, that address, 1, not being routable, 2, being self-generated, in a v4 world typically goes away when there is either a static or DHCP address derived into that OS. In v6, we have what's called this link local address. It's, again, a self-derived address from a reserved, well-known prefix, but it does not go away. That is a big, big difference in v6 from v4. It does not go away, and in fact, is the address that is used for all on-link traffic. On-link is your layer 2 domain, all right? The interesting thing about that is that all of your interfaces on any given platform could, in theory, have the same link local address because it's not routable. Now, with that becomes another use environment that if you have multiple interfaces and you want to use your link local address, you have to spec in your application, whether it's ping or traceroute or telnet or SSH or web, whatever, you actually have to specify the source interface, even if your link local addresses are different. And it's just the way the operation of using link local addresses is. So that has a whole nother set of kind of implications that go with it, but it's just part of the base operation. We'll see a little bit more about that here in a little while. Our route capable address, which we tend to call those the public, air addresses in IPv4, we call this a global unicast address. And that is your route capable to the public internet. Now, when I say route capable, it doesn't mean I'm going to route it. It just means it's route capable, all right? If you were to research v4 and go back to 30 years ago, all right, go back to 28 years ago, we didn't have, actually go back to about what, 26-ish years ago, we didn't have DHCP, BootP for regular, quote, networking devices. We didn't have RFC 1918. We didn't have any of that. Everything was statically assigned and using a, quote, public address, a route capable to the internet address. With those newer technologies, we got that automatic addressing assignment. We got RFC 1918. We got NAT capability. And part of that's, a lot of folks said, well, now I don't have to have public addresses and I'm not going to route to the internet, so I don't have to worry about it. Well, there's still security that comes into play. In a v6 world, we don't have NAT, quote unquote. There are a few NAT technologies that are used for transition operations, but they are not considered long-term, use them forever. So yes, we will have public addresses on the inside of our networks. We just have to do it like we did 20 some years ago and not allow certain addresses in and out. That's the only difference. Now we do have what's also kind of referred to as those private addresses in the v4 world, the RFC 19 address blocks, a unique local address in a v6 world. It is route capable within your domain, just like the RFC 1918 addresses, but we don't route it to the outside world. In fact, you should not. Likewise, you should block it from coming in, just like the internet providers would or any other connected. But you can route them all day long and you're inside. But there's just really no reason. Now, go ask half a dozen v6 practicing engineers their thoughts and use of unique local, and you will probably get at least a couple of different answers. I am not a fan of it. There's almost just really no real reason, but we'll stop with that because that's just part of my opinion. But at least we have those counterparts. In the travels of v6 journey, you'll pretty much see that what we know from v4 translates directly into v6 operationally, technologically. However, what doesn't translate sometimes are the words. We have different words in v6. We have some different operations in v6. But most of everything about v6 is still going to be about the same. Just a little chart kind of showing some of our addresses from kind of that special viewpoint from a v4 to v6 comparison. The two I really want to focus on here are the link local prefix. They're always prepended with FE80, typically : Even though it's considered a /10, we typically think of its use case as FE80 : /64 in how we use it. From the aspect of the route capable internet site addresses right now, IANA has allocated from the 2000 : /3, which means everything from 2000 to 3FFFF. all of the rest of the addresses before and after 2000 and say 4000 on are reserved by ANA, which means all of those other addresses are still available for allocation to be used. We haven't even really ticked in the use of what we have right now. So this is why we don't worry about assigning a /64 for a 2-point end-to-end, point-to-point looking interface. We'll still get a /64 network reserved for it. We might assign them as /127s, just so it's a point-to-point, but we still give them from a /64 address space. That's the basic standard. You can see the unique local down here. There's also a reserved 32-bit network prefix in the 2000s, but it's not routable to the outside world. You shouldn't, or you shouldn't accept it. 2001 DB8. And that's basically the documentation, example use. You can use it in lab, you can use it on your domain, and it will work. But if you were going to show examples, like you're going to see it, or have even seen in a few of mine, you'll always see them using that documentation address. Just a little blip of some of the well-known multicast addresses. We see a couple in our traces. Pardon me, the FFO2::2 and FFO2::1:2 for DHCP traffic. All right, you'll see potentially those addresses down in my traces a little bit later on. Can't get my little cursor to go down. There we go. All right. How do we get the interface ID? Again, going back to V4 and around 1992-ish, the internet fathers, the core engineering team, as V4 had been rolled out, and V4, or the internet was, or ARPANET really, was kind of going to the mode of a public looking internet. There was a discussion that, you know what, we are probably going to run out of these 4.3 billion addresses, because again, everything was manual and from one thinking, everything route capable. So we need another addressing capability, another protocol that has bigger addresses. The other thing we want is self-assigned interface IDs or host IDs. And the thinking at that point was, what can you start from that's unique? The other piece that we will do as part of this overall new network protocol is we will have routers provide the network prefix. The client OSs will provide their interface ID, therefore getting a 128-bit full number. Well, one of the most common things in every device is a network interface. With that network interface is a 48-bit MAC address that is supposed to be unique. With that, we have to take 48 bits, but fit it into a 64-bit space. So we need a few more bits in there, right? We need 32 more bits. Well, there was an existing, I said 32, we need 16 more bits. We need, or we used an existing IEEE standard known as UE64, which basically said, take your 48-bit number, split it in half, pad it with FFFE, and now you've got a 64-bit number. And the V6 teams kind of said, well, that's all fine and good, but that's a UE64. We would like something to have it slightly known differently, that it's a V6 usage of a UE64. So they took a bit that wasn't being used up in the first byte, the 7th bit, you invert it in this process of creating this 64-bit number to be used as an interface ID. And now we have a modified UE64 generated 64-bit address that we, or 64-bit number that we can use as an interface ID. And that's all great and wonderful. Nothing has to occur at the client. We don't have to touch it. We don't have to pre-configure it. We just turn it on and away we go. Well, the downside to that is that is easy to reverse out. And if I see an address with this in the middle of it, down between the 6th and 7th hextets, I know right off the bat what I can do to process that and find out its original MAC address, and with that I can find out that OID. With that, I can go up to IEEE and find out who that OID is assigned to. What vendor is using that OID? Perhaps I can now go to that vendor's site and find out what prefixes are used for what kind of devices. This translates to, I could find out, am I on a printer VLAN? Am I on a client VLAN? Am I on a voice VLAN? Am I on a camera VLAN? Am I on a server VLAN? What kind of a network am I on? Which will give me a whole lot more information. And I can do this in seconds by getting this address. So it came out a few years later, a little more than 11, maybe 12 years ago, a new RFC to say, let's instead generate a random number for that 64-bit use address. And great. And tell you what, let's take it to one more level and say, not only do we want to generate via random number, a 64-bit number, let's generate another one, and we're going to call that the temporary. And the idea of the temporary is that it would change on a periodic basis. And therefore, I am not as easily traceable. With that MAC address-based 64-bit address, I'm trackable. Jeff's here, Jeff's at the coffee shop, Jeff's at the office, because we know Jeff's interface ID is, we can just keep searching for that value. The random number process, by creating effectively two addresses, does a couple of things. That random number one is typically used for your link local and a global unicast address, and potentially even a unique local. The second one, the second computed address, is typically more used for this, only this temporary for a global address. And that's the one that will change. And that's the one that we would most typically use. The downside to that address changing is if you're doing any kind of single client to say server troubleshooting, and you've got Wireshark up and running, and that trace is running, and then just stops. But yet the application is still going. Well, it's because their address just changed. It changed on the fly. And part of the reason how that changes is these addresses now have two kinds of lifetimes, operational lifetimes. In a v4 world, your address is either good from it's live, it has time, or it's not. In v6, we've got these two values. We have a preferred lifetime, which is your fully operational period of time. We have this valid lifetime, which says, okay, after preferred, stop all new communications, compute for a new address, finish up your old comms on the old address. When you're done, it goes invalid, and we will drop it. So this is how you could, in that mode of watching traffic, see things happening, and then it just stops, just goes total dark. But yet the application keeps going because they got a new address, and they were able to slice it in very cleanly. You can readdress an IPv6 environment on the fly in the middle of production of the day, maybe, and nobody would know. Now, we won't do that because that's just not the way we're used to doing things, but it can be done, and it's largely due to this. So we have a little bit of that we sometimes need to, I would say, be aware of. You know, if you're working in v6, what address is being used and what might be happening if all of a sudden things just go dark, just up and disappear on you. In v6, we have this overall category known as the Neighbor Discovery Protocol, which does things like what we're used to as, you know, ARP and reverse ARP, discovering your neighbors, discovering other systems, all under Neighbor Discovery Protocol in this v6 world now. Is this overall operation. Same kind of thing. I need to know who my neighbors are. If I'm talking to them, I'd like to know who my router is. We have 4 of these that we very specifically tend to focus on in your early v6 travels. And that's these 2 for router and 2 for neighbor. Router solicitation, router advertisement. The router solicitation is, I am an operating system coming online, and I need to know, are there any v6 routers out there? If there is, a router will reply with a router advertisement. That router advertisement will give me bits of information that I need to know, like perhaps my network prefix, nowadays perhaps my DNS, perhaps my domain name. It will also tell me as a client OS, what do I do for my interface ID? Do I self-generate it? That's called SLAC, Stateless Address Auto Configuration. Do I ask for a DHCP V6 server? And if so, then I will send out a query as a neighbor solicitation, but it's in a DHCP looking DHCP V6 looking request. The router will tell me what to do in that case. And so router solicitations will occur as systems come online. Routers will also just periodically send out router advertisements, just not waiting for anybody to ask, just so that if anybody happens to come online and not ask, they can find out what's going on, as well as for informational updates. If I want to do network changes, I change my router advertisement and my prefix. So we'll see some of this traffic going through in here. When I come online as an address, no matter if it's link local, global, or EULA, I need to validate that address is good and that's unique. So I'm going to execute this duplicate address detection. We had a problem in the early days of running the DAD test, is that the system said, until you pass the DAD, you can't do anything else. Well, we were missing windows of time for systems to get logged in to back-end operations within corporate networks. And things were timing out because it was taking too long. So they changed the characteristic of how DAD is supposed to work or can work now to say use deterministic DAD, meaning get an address, start using it, still check for your DAD. If your DAD passes that it's unique, you can keep going. If your DAD fails, you got to stop using that address and try again, which unto itself can present some issues naturally. This is that wink, wink, nod, nod moment. If you think about trying to do even kind of, I'll just call it a DOS, kind of attack, you can basically sit there and answer every DAD request, say, yep, that's me, yep, that's me, yep, that's me, and nobody will ever get on the network. There are potential mitigations against that as well in infrastructure systems. And just kind of one of those things to be aware of. It's got a very unique characteristic when you're looking at it, and it's this very last line down here, and that the source address is a double colon. All right, so you will see that, we'll kind of see that in some of my traces going around. Now, I made a comment about the router advertisement, and it is or comprises bit or flags in it that tells a client OS what they are supposed to do from an interface ID or a host ID component, i.e., are you going to do Slack, are you going to do DHCP, are you going to do some sort of hybrid of that? And this chart basically tells you of the 4 key flags in a router advertisement. There are many more, well, maybe not many, but there are a few more. But these 4 flags and their state is what tells a client OS what to do. And this becomes really important because a lot of the vendors in their infrastructure OSs, i.e. network OSs, firewall OSs, those that can do routing, V6 routing, will show you how to set all those flags. What they won't tell you necessarily is, well, which flag should you set for this operation? That's where this chart came from. In my early V6 play in the lab, I turned on all the bits. The next thing I know, I had a whole bunch of addresses, and I'm like, no, this is not what I want. Why am I getting this? Well, it's because I had all the flags on. So if I want to use the Slack process, meaning the interface ID is self-generated, I want certain bits on. This is actually the most typical default setting for router OSs. If I want to use a DHCP V6 process only, then I literally need to turn off one flag, the A flag, and turn on the M flag. The A flag is for basically the auto config, and the M is for the managed config. We'll see a little bit of what that looks like in the traces a little bit later on. The DHCP V6 process follows very similarly to a V4 DHCP. It's just a different acronym. If you're used to the DORA acronym in V4, in V6 it's known as the SAR. So when, as a client OS, I'm instructed, there's a key word there, and I'm going to come back to that in a minute. If I'm instructed by the router advertisement to make a request to a DHCP V6 server, then you'll see we had a router advertisement come through. My client sends out a solicit message, which basically is an all points multicast. Well, it's an on-link multicast. It's just like it is in v4. All right. Any DHCP V6 servers out here? If there is one, they will reply with a, yeah, here I am with an advertise. I'll follow back up with, can I have an address, please? And they'll follow up with, well, sure, here's your address. All right, that's the SAR acronym. Again, same basic process. Now, the reason why I said instructed is that some operating systems don't necessarily configure from, I would call it an exact configuration. Microsoft's client OS is that one. The V6 protocol component in Windows, I lost my Vista, where they introduced V6 capability, but strongly and worked very, very well from Windows 7 on. When you go to configure your V6 interface, you tick the box. Well, nowadays it's also automatically ticked. You can go in and either statically assign address, or if you don't, it has the basic functionality of it's going to do a DHCP V6. Well, in fact, the Windows Client OS then will actually send out a DHCP V6 message, even if a request. It will send that solicit message, even if it wasn't instructed to do so. And if there is a V6, a DHCP V6 server available to that subnet, that client will get an address. They asked, they'll get one. But they may also get a Slack address if that's the way the router advertisement was configured. I'll show you an example of that here in a little while. Well, it doesn't really matter what they were told. They're going to get, potentially multiple addresses just because of the way the OS works. Now, you potentially can go in, even in these OSs, and turn that functionality off. That's a little bit more work, but we can still go around it. There's a lot of talk about, well, I'm running on v4. I've got systems that aren't going to support v6 at all. I've got applications that may not support v6. Oh, I'm talking to the outside world out on the public internet. They're not some systems doing v6 yet. So I need both protocols. And we actually refer to that as dual stack, where you would run both v4 and v6 in your network. But that's also considered a transition mechanism, meaning you don't really want to run dual protocols. There's a lot of extra work that goes into that, not only in the infrastructure, but at your firewall, or let's just say at your security point. You've got to have double sets of rules. Everything that you're allowing and blocking in a v4 environment, you've got to duplicate for v6. You can't just say v4 and v6 do the same, because they're two different protocols. We would like to go to v6 only. In fact, the noise of recent time, this is within about the last year now, is strongly going to convert to v6 only. In fact, U.S. federal government has issued a now newer mandate that's got serious teeth from the aspect of all government and military systems are supposed to convert to v6 only within about 4 years. And it's a phased approach. They've been talking about doing it for over 10 years, but there was never any you must. Now there is you must. And one of the ways we could go to v6 only and not even do a dual stack is put in a system to get us through that v4 access hurdle. We know this is these two components of NAT 6.4, DNS 6.4. Foundationally, what happens is if you're a v6 only system, you're going to ask for a name resolve. You're going to hit your DNS, but it's going to go through a DNS 6.4 box, and it could actually even be a real DNS itself. What's going to happen is it's going to convert that v6 type request into a specially formatted, okay, stop. Jeff made a mistake. I'm making the request as a v6. The record in DNS is only an A record. We're going to convert that request at this DNS 6.4 box to a v4 for an AREC request. The AREC is going to come back through the DNS 6.4. It's going to convert it to a specifically formatted v6 looking address. And now I can do my v6. It's going to hit my NAT 6.4 box and get converted back to v4. Go out to the world and back again. This works, and it works well. And now I can, over on my client, really easily convert to a V6 world and not worry whether I'm going to internal or external V4 only systems. And this is starting to occur now a lot more. This is becoming more accepted, and to not even do a dual stack, just go straight V6, put in a little NAT64 DNS64 operation, because we're only dealing with these, small values. We're not processing data here. We're just trying to process those, the early part of the prefix, and modifying those prefixes back and forth for the address is kind of our new way of doing things. And we're seeing a lot more of this functionality. I've got an example of this to come up here in just a little while as well. I could be V6 out here accessing V4 stuff all day long, and I don't know the difference, and nor do they know out here that I was running V6, right? Because everybody's getting what they want. It's fun stuff. Let's talk a little bit about the applications in V6. There's a browser add-on known as IPv6 foo that is available for Chrome, and one for, I guess it's IPv6 foo for Firefox as well. The nice thing about this little add-on is it will tell you or show you what addresses are being used. Both kind of that big number 6 tells you your primary address is V6, and then you've got some V6, V4 mixed into that as well. So it's a nice little way of looking at when you're browsing around what addresses you might see. Like this, going to this Cisco site here, we see, yeah, there's some V6, but look at all that other V4 servers that are being hit. Some are Cisco, some are external. And we do see a little bit of that going on as well, where these addresses are still, to do the job, to render that web page, it's going to a lot of places. A lot of these places, especially if they're not controlled by the entity, they're still V4. So that little utility is really handy just to kind of see what's going on. I don't think it works on the Chrome version of Edge. I actually haven't tried it. I just thought about that today. So we'll kind of see how that goes in our travels moving forward. Another site, this particular site, as it comes up here, you'll be able to tell that all of the addresses that it's going to on that particular site are V6 addresses. And it's not too very many sites as well, but it was kind of fun just to see that in operation as well. Plus a shameless plug for a book that I was a co-author on. If you want to use a V6 address in the URL, you can, but there's a problem. There's a lot of colons. And if you remember from a V4 environment, the colon was the delimiter for a port. Well, now if you put that address just as https://2001:0 blah, 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 the browser's not going to know what to do with it because it doesn't know how to parse. It sees that first colon and says, oh, parse it to a port. Well, everything about it is wrong. However, if you wrap that address in square brackets, the OSs know what to do with it. Now you can put your colon to get to your port, and away you go. Most applications are supporting this. Now, a homebrew, home designed application may not know to do that yet, okay? But it definitely should be able to in the future. And so that's how we can actually put an address in there, make it work in a lot of applications. What's more interesting is we're starting to see, maybe we overall are starting to see more applications through time now, over the last probably 5-ish years, that the application is able to determine that's a V6 address or a V4 address, and even maybe parse out, oh, the first 128 bits of that value coming through, because I know what to do with colons, I know what to do with double colons, then I might have a colon for a port. So it's really interesting seeing some of these applications, and I'll show you an example of that here in a little while as well. Here's an example of going to, in this case, a switch URI through just its, in this case, global unicast address and rendering out. And so we can have a little fun using just addresses. Probably not what we're going to do all the time, but even if you're just playing with it, working it from kind of a, a testing learning viewpoint, that is one of your options that you might want to kind of play with. All right. Next in our travels, looking at applications, trying to use a link local address in the URL. Well, it kind of worked, but my recent play in this over the last almost year is it's just not working anymore. I don't know why. I've tried it a couple different ways, but almost all of the new versions of the common browsers, it's just not working. And I would guess it to be, well, we just don't want you doing that. But the problem is, in theory, that's the address I should be using if it's an on-link system. But nonetheless, if it works in your environment, awesome. If it doesn't, it just may be that mode of it's just not going to necessarily. Here's an example of using TerraTerm, going to a V6 address, SSH, wrapped in square brackets. Then I can see over on that switch, here's where I came from. All right, the SSH session is right down here. You can also see with that, it's in uppercase. It is doing dropping leading zeros. We can tell by the 470, the BFO, the 136. Okay, there's a leading zero there, but it does put its hex characters in uppercase. That happens to be at least some of the old platforms of Cisco IOS. Want to do a network type, another network type utility, TFTP. We can do that in V6. The interesting thing here is that this operating system didn't require me to put that address in brackets, but I want to copy my running config over to a V6 capable TFTP server, and we see that it did work. All right, the system made a connection and dropped over our config when we did a copy of that config. So again, examples of some OSs requiring brackets, some OSs not. RDP, at least Microsoft's version RDP, you don't have to use square brackets. You could just put in your V6 address and go across. Now, I do think, though, if you want to use a different port than the traditional RDP port, you have to put in the brackets. I don't think it parses that far out, at least not on some of the older ones. I actually haven't tried it in, say, one of the latest Windows 10 platforms, but the interesting point, 10 years ago, this was working without any kind of a change. So that was kind of fun doing RDPs over V6 without having to deal with that. So just more examples of doing that. A quick little note about some of our other, say, network kind of core operations. In this overall platform, we need this quad A record, which is similar to the A record, in order to do name resolution. So I'm going to ask for a resolve to www.company.com, and I'm going to ask that as a quad A request, looking for that V6 return. If I just simply ask for an A request, I'm going to get a V4 address back if it exists. In this particular case, from a bind configuration, when you want to do your reverse configuration, you have to bring out basically every nibble, every 4 bits. You can't put it in traditional notation. You can't do it in colons every 16 bits. You've got to break it up in 4 bits and with dots. Not all DNSs necessarily operate that way. That just happens to be an example of bind. I will also give a caveat that this is probably about a 6-year-old screenshot. I haven't tried a newer version of bind to see if that has changed, but at least gives you a little bit of an idea from kind of that VNS perspective. An added point to that, I would say 8 years ago, in a kind of a dual stack operation, or with V6 being a now enabled and default protocol, even if it wasn't being used in client OSs, what would happen is, because it was the preferred protocol, you would do a DNS query. It would first do a V6 quad A request. If it never got that, because 1, you weren't even running V6, 2, you weren't pointing to a a V6 enabled DNS server, you would eventually get a timeout. If you're dual stacked, then the operating system would do a V4 AREC request. Well, the problem is applications were timing out. So they introduced the capability, what we called happy eyeballs, RFC, to say, if you're dual stack enabled, ask for a quad A and an AREC request resolve in both protocols. So your V6 is asking for a quad A and an AREC. Your V4 is asking for a quad A and an AREC. And the overall thinking is, hopefully you'll get a resolution. You'll get a response in one of those two protocols in one of those two modes, one of those two resolutions. And keep going. That's the whole idea. It's really, really mind-blowing thinking about V6 and quad A's and all of this and watching a DNS request, and from V6 you see it doing an AREC request, it gets an AREC reply. Well, unto itself, the V6 protocol goes, well, I don't know what to do with that. It just ignores it. But if you've got V4 enabled and running, V4 goes, woohoo, we got a V4 address, we can resolve, we can go to that site now. So there's a lot of interesting things that go on in this world of the protocol and the protocol operations. If you're not familiar with V6 yet, fire up a little miniature lab, all right? Just fire up a couple of systems on a little private network, or fire up a couple of VMs, or even just bring up a system unto itself. You can do some stuff. But if you got a couple of little somethings, virtual machines, a couple of Raspberry Pis, just something, you can have a lot of fun in learning about V6 and how it operates. And to that end, if you want to really look at the protocol and operations, fire up your favorite protocol analyzer. Mine is Wireshark, and use your display filters. There's some built-in V6 display filters in Wireshark to help you in that journey. There's just a plain everything IPv6 filter, ICMP V6 only traffic, DHCP V6 only traffic. Now you can build sub-filters from there on your own, and I'll show you that. But using these filters from the aspect of, I don't need to see all that V4 traffic. I don't need to see my infrastructure traffic. I just want to look at V6 specific traffic because I'm trying to learn it. And so you can do that. One of the other things that I do in my Wireshark view is I assign specific colors to specific V6 traffic. Remember my earlier talk, a router solicitations is a client saying, routers or a V6 router, are you out there? I color that traffic of a specific color. In my world, it's pink. All right. The router advertisements, I color those red. Why I do this is twofold. If I'm watching a live trace, I want to see red packets every so often. If I do, I know I've got a router online and it's working. If I see pink packets every so often, then that means there's clients coming up and down. All right, or I guess coming up, maybe they went down, they're coming back up again. I expect those color packets. I don't necessarily need to focus on them unless I'm actually troubleshooting, but as long as I see them, I'm happy. Similarly, if I'm using or looking at a static saved trace, I can scroll through that very quickly. I can even look over in newer versions of Wireshark and look at my color bar and maybe find red and pink over here and go, okay, it's V6. Yes, I see some traffic that I expect. I can then focus on it from a display filter down the road. I can also see other colors of traffic in here. I can see my ICMP V6 traffic. I can see my DHCP V6 traffic and others as well. If you're a fan of Wireshark and a fan of color rules, create some specific V6 color rules to even help that journey a little bit more. Looking at those display filters, again, you can get an idea here of configuring these for very specific V6 use. ICMP V6 type 134, 133, basically router solicitations, router advertisements. I want just that level of traffic. We'll see some of that as we go through. You can type these in the display filter bar. Likewise, you can actually, in the display detail or the packet details view, right click on a protocol component and configure your filters, meaning you don't have to know the syntax. You can just say, I want to find everything that's a neighbor solicitation and build a filter for that, not knowing that it's an ICMP v6 dot type equal 135, right? Way faster just to navigate to build this. This is not just for IPv6 work. This is a generic use feature for everything in the environment. They've added a new feature last fall for what we call nested display filters, because is what was happening. A lot of us were building so many display filters, we were running out of space on the line. We were having to click on a double arrow drop down, and yeah, it got a little confusing. Now it's a lot more fun. I can build these display filter groups, and I can have less on my display filter bar, and it's more concise in the operation. I'll show you what that looks like. Oh, a lot of us just loving that new feature. We can kind of see down here what it looks like. We see a few of these nested display filters, and then I see a few that are not. They're just standalone. So it makes it even more fun using all of this. How it works is you would create these filters and then prepend them with a name and then a // and that makes it a drop down and a grouping. So you can see a couple of the different groupings in here that I've got. Another neat feature they added at the same time last fall was the capability of displaying a packet diagram. This is really cool. I would say, though, from the early days or from a specific troubleshooting. One thing, it takes a bit of real estate to really bring it up, okay? But two, if you're starting to learn or troubleshoot a particular protocol, V6 or otherwise, if you click on a specific area of the packet details, it will highlight where that lives within the packet architecture, all right? And it can be very helpful, again, in that learning phase. In my typical Wireshark view, I keep that mostly off to the right, so I can quickly bring it in, but it's not consuming a lot of space, not a lot of display room here. So that just happens to be the way I do it. How you get to that is you would go into Wireshark's preferences, you would go into layout, choose whichever your layout is, and then choose which component you're going to show into which pane in your layout. So you can kind of see what I've got there. And this is a per configuration profile view. You may have some views where you've got the packet detail or packet diagram looking. You may have some that you don't. So a lot of flexibility with that. Okay, let's wind this down a little bit. Talked a lot about V6. You can go to this reference point, and I'll put that over in the chat here in a few minutes. A little cheat sheet I put together. There's a lot of them out there, and like everybody, I wanted one with everything that I thought was important, and so I put this together, openly available. There's no secrets here. Just kind of put some information that helped me, and figured I would share that out there with the world. As far as resources, we're going to call it books on V6. There's a lot of books, and they've been within about 3 timelines. We've got books that are 20, 21 years old when V6 first was ratified, basically in 1999. There was a number of books that came out. We fast forward to about the 2010s to the 2008 to about 2012 kind of time frame. And that's when a lot of updates came out. A lot of updates to the protocol came out in the RFCs as well. So there's a lot of books. I was invited to be a co-author to bring in V6 and the Guide to TCP/IP, which was a textbook. There's a number of these books you're going to see. They have particular focuses. The Guide to TCP is mostly telling you about both V4 and V6. It's a half and half book. We go through the RFCs in great detail, but there's examples, there's miniature labs in there. So it's a good start point book, if I do say so myself. This IPv6 security book written by Scott Hogue and Eric Vink is a great book from a security thinking viewpoint. If you look at the copyright, you might feel it's dated, but it turns out that it's still current and accurate today. The protocol has changed to some minor degrees, but everything that you need to do from kind of the security thinking aspect in an infrastructure environment is still very, very valid. Scott and Eric have talked with the publisher about updating, and everybody's just kind of like, it's just not a lot, just almost no real reason. The book Practical V6 for Windows Admins by Ed Horley is a Windows thinking, kind of book. He's focused at that time on Windows 8 and Server 2012 as it was coming out. He focuses a lot on using PowerShell commands as well as GUI operations. So it's V6. All these books have V6 foundations, but they also have their kind of, again, their specifics. So it's a great kind of Windows focused looking book. Tom Confine's book on address planning, V6 address planning, is great. We still say folks are going to probably readdress their V6 world 2 to 3 times, just because the first time a lot of folks get real conservative because they're still kind of thinking the old V4 addressing ways, and then they figure out that I don't have to be conservative and we can redo it. And so Tom will kind of talk you through a lot of those. Sylvia Haugen's book on V6 Essentials is a great, just basics book. A lot about the V6 protocol, what's the differences, how you're getting it in there, lots of examples from varying aspects in the V6 journey. Rick Graziani's book, V6 Fundamentals, is a Cisco Press book. Rick is a university instructor as well as a Cisco instructor. And so this is basic V6 also with a Cisco networking kind of focus and examples. Another great resource that Rick did. Joe Davies' book, Understanding V6. Joe's been doing V6 since Microsoft started doing it. He's the original internal author for a lot of their documents. Came out with this book, updated it. Again, a little bit of a Microsoft focus as far as some of the utilities and whatnot, but a great resource to have. A little bit more on the troubleshooting side, we've got a couple of nice books out there. Chris Sanders' Practical Packet Analysis is a little bit more kind of Wireshark use generic, but he's got some nice bits, a good chapter as well on V6 to kind of help. And even if you got it just from the not much V6 content, but still everything else about it, you could apply it straight into a V6 protocol. Similarly, Laura Chappell's Wireshark and Network Analysis book, a strong V6 section plus other V6 bits sprinkled in. And so they're great references. I own all these books. I know all these authors. I've worked with all these authors to varying degrees, some more than others. Just lots of great information. Most of the book references, though, haven't been, I would say, published since about 2015, maybe now. Some of us have been talking about, well, do we do some updates? And yeah, there's been some RFC updates, but most of them haven't been so drastic that it would cause such a major change, major update in these books. Yeah, it would be nice to update them, and we will probably see some of this as we go forward. So I'm not done yet, but I want to say thank you for coming in, taking the time out of your evening or part of your day, whichever part of your day it might be, to come in and listen to me ramble on about V6. I love playing with this technology. If I could do it full time every day, I would. I'm not in that point to do it, but it is a lot of fun. So I do thank you, but there's a demo. We're going to talk about some of this V6 stuff, and I want to show you some of this in operation. Okay. Before I forget, I promised I would put the link in the chat for that reference guide, so we'll just throw it. I'm looking in chat, and at this point, I haven't seen any questions. So again, if you have had something to question on, you can certainly feel free there, or if, as we're going through things, again, you can certainly follow up as you might want to. Okay, so what you see now that I'm sharing is a static trace, a trace file that I use basically for show and tell. Right now, you can see V4 and V6 traffic in it. Well, this presentation is all about V6, so I don't want V4 stuff. So I'm going to click on my ready, steady V6 filter button here. And if you come down to the very bottom kind of right corner in Wireshark, you will see that out of the 92 and change thousand packets, almost half of them are V6 and the other half are V4. So that is more or less to say it was probably on a dual stack environment, but doing both protocols somewhat actively. All right. And now we can even see from this one screen, there is a phenomenal amount of information that to be had. All right. Just look at a couple of the protocols. I see I've got OSPF version 3 running. on here. It's OSPF talking with V6 addresses. I see this router advertisement. I see some DHCP renew replies, which is basically the mode of I had an address, can I keep it? All right. We see some other V6 traffic. All right. We see these link local addresses in here at this point. We see some of these multicast addresses. There's another really, really important bit that I see here that almost would startle me within seconds. I see 2 red packets, 2 router advertisements at 2 different addresses, one at FE80::5 and one at an FE80::UE modified UE64 address. Look at that, FFFE right in the middle. The rest of this, it's probably going to be based on the MAC address. Well, the reason why I say that might alarm me is because I built the network. I know what to expect. More importantly, my router has a statically configured link local address of FE80::5. So when I see this other router advertisement here, I know that's not my router. That's a rogue router. Well, I'm going to call it a rogue router. I'm going to call it not a router I configured, so it's a rogue. And so one of the things I'm going to do really quickly here is I'm going to execute a filter to just look at router advertisements, because now I'm curious, how often does that other router live out here? So we see it in these first few packets. We see 2 V6 routers sending out router advertisements, and then a break, and then, oh my goodness, look at that. This tells me that there may be a problem. Now I could give you another tidbit of information. What also occurred, oh, and look, my router changed even. That's okay. Is that we got a report from the user community that there's some folks having some intermittent access not capable. You know, web pages not found, applications are not working, the application timing out. And as I look at this trace, look at this information right off the bat, I say, well, then that means there is probably something different in these router advertisements, and these clients are possibly getting different addresses, i.e. not working anymore in the network the way I want. So the first thing we're going to do is we're going to look at this router advertisement from the known good router. We're going to go down to its details, and I expect to see a few things. One, I want to know the network prefix that I am telling my clients to be on, or that I'm operating on. All right, and the details of that prefix information section, I want to look at these flags, and very specifically in this case, the A flag. The A flag is turned off because up in this other flags section, I have the M flag on, which tells my clients to do DHCP. All right, meaning, yeah, this is our network, and yeah, I'm your router, but you're going to get everything from an addressing viewpoint from a DHCP V6 server. Hope it's out there, because that's what you're supposed to do. If I look at this rogue router packet, I can immediately see the M flag is turned off. It's a completely different network prefix, and more importantly, its A flag is on. So the clients, any client OS is supposed to take the action to which the router advertisement told it. Now, those client OSs all react somewhat differently. And it doesn't even not just say Microsoft Windows, Apple, Mac OS, Linux. You cannot use anything even like those generic terms. It is which version, which patches, which add-on, time of day of week, moon phase, how many kids you have. I'm just kidding. But you cannot put one operating system in a given category. Some will drop what they had and act on their new. Some will wait for their time out of their old and then act on their new if it's a recently new instruction. Some will do bits of both, all right? Some have changed what they did as opposed to what they used to do. So if my reports are up and down, meaning they're not getting to their applications, the next thing I would like to do in looking at this was how much DHCP V6 traffic was there around these. So I've got another filter that looks at router advertisements and DHCP V6 traffic. And what I expect is when I see my router advertisement, all right, I expect to see some DHCP V6 traffic, and we do. If you look at these times, you can see they're close. But when I see the rogue router advertisements, I don't necessarily see some traffic, although here we did only because we did a release. This OS did a release of an address. We see a couple of other of these rogue router advertisements and no DHCP V6 traffic. This would be the time that the applications didn't work. Then mine comes through, life looks good, and they're working again. Oh, and then they're not. And then they are. And then they are. Oh, then they're, okay, you get the picture. All right, and then we switch over to another network and we see some similar activity. And remember, I picked all of that up in the first few seconds of just that window. But I did it because of a couple of things. One, sure, I would say trained. I've trained my eyeballs to do it. But two, also by just using some of the functionality of Wireshark. Two key operations, the V6 protocol filter and colorizing my packets. And then that way I can simply spin through here really fast and I can see a little, see a pink went by. Okay, that was a client asking for an address. I can't even find it anymore. I went so fast. All right, oh, there it is. All right, just the little things about that. I can see all this different kind of traffic. You can click on your color bar and more quickly navigate to certain areas within your trace view here. And even if this was a live trace, I could very quickly, again, determine what's going on my network to either learn new or troubleshoot, whichever, or it could be a hybrid. One of the other things to do if you are a Wireshark user is to, in your journeys especially, or on a production network, find packets of interest of known function, like this is the good router advertisement, this is the bad router advertisement. Make a packet comment to that effect. All right, it's a feature. Pick a packet, right click on it, select packet comments. And this already even has one. First RA seen, it's the correct RA. Did I make one for this one? Packet comment. Yes, it's a rogue router. A flag is set, M flag is off. If you put these comments in there, you can also just click on a quick little display filter and look for all the packets that have comments. And we can see things like what these comments are down in the metadata. And we could see that was a good response. This is a solicit message. All right. It's a particular DNS query. All right. And my comment here was, yeah, this is all good, but look at its source address. It's sourcing from that bad actual address that it got earlier, but it was actually sending it, trying to send it. And it could even be that the rogue router will forward that packet. The rogue router capturing all that traffic, woohoo, device in the middle. All right. And still allowing great traffic is just capturing everything. So you can make these packet comments, and it's portable. You can pass this off, especially if you're trying to blame another team for configuration problems or issues, and say, here's a trace. I've noted the packets of where the problem is and where it isn't. Go fix it. Or if you're just trying to share information with a vendor or another entity, a colleague, whatever it might be, throw this in there. That way, all you have to do is send the packet as an attachment or put it up in a share site and just basically say, go look at the packet comments. Type in PKT_comment in Wireshark and it'll just bring up all those packets. So out of 92.5 or 92.25 thousand packets, I have 5 that have comments. All right. A great use of the application here. All right, so back to just regular V6 traffic. That's a lot, and you can kind of see a little bit of how I'm using it here. Again, this was a dual stacked environment, but I was just trying to show in V6 only, kind of look through here very quickly. My comments about having the packet view over here, we can click on that and let's say, well, again, where is my piece? Where are my flags? Where do they live? Well, they're down here. You're not going to get the details like the looking in the packet details and expanding that out, but at least I know where the flags live, and I know how many bits are in that flag. I just got to work through the rest of it. So a lot of this can help out as time goes on, again, in the bit of the learning journey, but you might take it off the side. I kind of leave it and keep it over just like that. As another little, for instance, remember that rogue router had the different flag set. I actually have a different profile configured where I show those flags and my columns. I created some specific columns to show me the router advertisement. So if I, one, bring up the router advertisements, and two, bring up the flags columns here, then I can see, you know, which flags were set, the 4 flags in particular. And so this was just again, a little bit of a configuration profile that has this specific view. I only need this when I'm troubleshooting router advertisements. Otherwise, I'm going to go back to my other generic V6 view that also has a packet diagram. And so I can flip back and forth that easy and be able to work through. You can see I've got a lot of different configuration profiles for all kinds of traffic, not just V6, but definitely a few in here for V6. Okay, that's a little bit about V6, looking at it in detail, looking at it from a kind of a protocol component. So with that in mind, let's do a few other things. So just kind of a quick view here. My particular world, I am dual stacked. Okay. However, my provider does not give me V6 addressing that I can route with. They actually provide a single /64, but that's on their side of the world, which is on the outside of my firewall. I can't use it. It's just like, really, just take it away. You're not giving me anything of real value. We need a /60 at minimum at Jeff's house. Actually, I want a /48. I'm greedy. So I'm actually using a tunnel provider, Hurricane Electric, 18.net or tunnelbroker.net. To give me free, completely free tunnels. And in fact, I've got both a /64 routed to me and a /48. I am just crazy with networking. And so all of my V6 traffic tunnels through their system, in this particular case, through one of their tunnel colos in Dallas. I am over in Fort Worth, so it's logistically close, internet-wise, who knows, but I'm doing real V6 because I can do things like, oh, ping, there's this particular location, 2600 : This is a site owned by Sprint, and Sprint is nice enough to give us, thanks, Joe, Joseph, my bad, to give us this address, and you can ping. So if you're starting to play with V6 and you want to test it, ping 2600 : all right? Ping google.com. Google's a big time V6 entity, all right? My other favorite I was talking about earlier, ping facebook.com. And take note, look down in there in the 5th and 6th hextets, Facebook. Again, there's 32 bits I don't have to worry about. Here's 64 bits I don't have to worry about. So now I'm down to the point I only really need to try to do a recon on 32 bits. Wow. Okay, just wow. But it's cool. It looks fun. Keep your words in your labs. Don't put your words, your hex words, and a V6 address on your public route capable addresses. Okay. It may look fun, it may make life of thinking a little easier, but oh my goodness, Red Team, thank you a lot just for doing that. So lots of different things that I could potentially ping here. I've got a few devices on my network. I'm going to bring up my little shortcuts over here. Got a couple of computers on varying networks. This particular computer is on one of my subnets or sub V6 addresses, but I've broken it out. One, I can't type apparently, and two, my copy paste didn't work. So let me try that again. And I'm going to go to a few of these addresses here in a little while. All right, so we're going to ping that. It's a public address, but it's on a different network. I've got another system here, and it is on my ISP's network, but it's on their side. It's on the outside of my firewall. All right, it's that /64 that I can't do much with. Oh, well, I can play with it here. I've got another address here through a tunnel provider, Untitled, and that provider is actually over in Sweden. And their tunnel, row. Okay, I'm going to slide out of view here for a minute because I've got to make a quick little update on that system. I guess it's on a wireless network, and occasionally it drops off. So you bear with me for just a minute, and we'll need that system back up anyway. But that's going literally across, the pond, the big water, and coming back again. Only if my device was online. And again, I don't know why it drops. I just know it does. So I will come back into view here in just a second once I effectively bring this back up, and we'll get back on it. So those are kind of the fun things with those addresses and playing with different addresses in a V6 world. All right. So if we think of it from going to varying sites, and I'll show that here in just a minute as well. Oh, I'm sorry, team. Let me get this. Let me make sure I get this right. Hopefully I did. We'll see if it comes back up. And while that's working, I'm going to do this. So bear with me for just another moment. I'm going to bring up my Chrome browser. I'm trying. It's just like everything. Oh, look, my system came alive. Yay. Finally, I was trying to bring up my Chrome, but not my normal Chrome. So it can give you a few things to show. So that system's alive. So again, that's going, across the pond and back, and it's sitting 6 feet away from me, but now it's working. So if I go to a few places, we'll just go to Cisco. Again, they're nice and easy to go to. And you can see up here my IPv4, and again, you can see all those sites that it's going to. I can go to a little site that I've got, 4 to 6 labs. You can see it's going V6. It's got another little V4 address that is going to behind it, as well as yet another V6 address in here. Bring my browser back up a little bit. Okay. I'm trying to think of, here's one of the things that gets a lot of comments out there. Twitter. Twitter is a V4 still environment. They get commented to a lot from people going, Twitter, hello, aren't you coming into the real world? We are in the 21st century here. If I could type, we go to Google, we can see Google, and at this stage, all those sites are all V6. All right, Facebook as well. Go to those. So you can have a little bit of fun in part of your journey if you install the IPv6 foo, add-on, and get this, and it helps. Firefox and Chrome, this works in. So we have a little bit of fun and kind of the proof of, yes, not only did we really know the system is V6, we really know that it is. All right, I can stop that ping now. I can stop that ping. So we see a little bit of action going on here. If I bring up Wireshark on a live trace, just to kind of show you what that looks like here in my world. And it's going to take a bit. I've got a lot of adapters on my system here. So it takes it a few seconds for Wireshark to come up. And I'm going to try to talk through it all. But I want to give you a little bit of an idea of what's going on here on this network, and we'll just bring up V6. So I click that. If you notice, just brought up my V6 only traffic, and we can see we've got all kinds of traffic. We'll just kind of pause this for a second. This is all global traffic. 2606, 2001, 2803, we're going all over the place. All right, different kinds of traffic. If I filter it down, to say just router advertisements, I don't have them super frequently, but I did catch one, right? And we could see here my system. And it turns out that this is my firewall, and it's a Fortinet, and it's running version 5 something code, and I'm not able to statically assign my link local address. I'm actually very unhappy about that, but I also haven't checked their newer versions of code to see if it supports it. So I can't, but I've got all the rest of my functionality configured in here. I've got the A flag off, I've got the N flag on. Okay, so we see that, all right, that's the router, life is good, and all is well in this world. And you can kind of see I've got my router advertisements coming fairly frequently. The more typical mode is router advertisements should come out about every 6 to 10 minutes. Not set in a standard definition, but about the way I'd like to run it. If I look at Dhcp V6 traffic, I really don't expect to see much live right here, on my own client, and I'm not tapped into the core of the network to see if there's others going on. But nonetheless, we can see it. Look at this ping traffic, and I'm just going to fire this ping up one more time. But we'll take that T out of it. And we come back into Wireshark, we can see just V6 ping traffic. All right. So at this stage of the game, this is, I would consider, all very normal. There's nothing in here that I would consider unusual or surprising or anything like that. Let me back that off one step. But at least it's live, and I'll just kind of go back to this all V6 traffic, kind of keep you being able to see that as we go through. So we've seen a little bit of web traffic on V6. You've seen a little bit of just traditional, command line, which is regular old pinging, a regular ping looking bit of traffic. I've got a session to a console server here in my lab running. So my console server is on actually yet another V6 subnet from another one of my Hurricane Electric tunnels. Hurricane Electric, for these tunnels, they're completely free, will let you have 5 different tunnels. Now to have that tunnel, you have to have a static or at least a pingable address to build that tunnel. So if your provider doesn't even give you a static IPv4 address, but if it doesn't change, you might still be able to build the tunnel as long as it's pingable. If it does change, but not very often, you just go into your tunnel configuration and change it. And so you can have a lot of fun with that environment. And I closed my browser window. Oh wait, maybe, no I didn't. Go to tunnelbroker.net. And effectively, again, you can see a little bit about their system. There's no guarantees. There's no SLA on this. I have been running tunnels with them for over 10 years now. Now, not that long consistently, but I had a couple systems that had live tunnels that the only reason they dropped was because of me. They did not drop for any other reasons whatsoever. So while they don't guarantee any kind of uptime, I've never had a problem other than something within the net or the infrastructure, or during the Texas snowpocalypse, we had some power outages, right? But past that, those tunnels are rock solid in this environment. So again, this particular one's going to a terminal server, and then I'm accessing a router out here. And one of the things I want to show you is this happens to be an Aruba network switch. If I do a show IP, which would show me only IPv4 addressing, we see there is none. But if I do a show IPv6, we find out that this is a layer 3 switch configured only with V6. And I've actually got this is kind of like the my side of the network, and this is a private network that it's got. And you can actually see these are different prefixes. This is from Hurricane Electric, my 64 net prefix, and this network down here, 201.470 BA04, is my 48-bit that they very nicely give me. And then I've got it down into Cafe. Well, I've actually got a client over on that network, and I have that client that I can RDP to them. And so I've got some pre-built RDP configurations. And I guess what I should have shown you, and I apologize for that. Let's just go ahead and bring up that connection. And you can actually see I'm RDPing on V6 to that cafe address. So I'm looking at the top of that Windows bar, but you can also see it down here. This is on that computer, and you can see it's on the cafe network. And just looking at this address, all right, this IPv6 addresses, all right, we can tell a lot. I can even tell even a few more things. I can tell my router address. I can see my link local, FE80, and then look at this. There's no FFFE here in the middle. So this means this was derived through the random number generator process. That is the Windows Client OS default, has been since Windows 7, basically. It generated this temporary address, but it also generated this static GUA address, global unicast address. But look at these interface IDs. They are the same, all right? Yet this one is different. This temporary address will change, but the methodology that was engineered into this used to be that it would keep this address for 24 hours, assuming that interface stays alive. At the end of 24 hours, because it had written that address into soft registry, it'll basically request the same address. And as long as that same address is available, then it will keep using it. If that interface stays alive for up to 7 days, at the end of that point in time, it will now drop this one and ask for a new one. So over time, you might find on a client multiple temporary addresses. And if you looked at them in detail with a NetSH interface IPv6 show adder interface equal 12, you'll find out the lifetimes of those addresses. And we can see here in this screen that this GUA address that is fixed is only good for now less than 2 minutes. All right. This other address, which was the temporary, same, but yet this link local address is good forever. It's fixed. It's finite, or infinite, not finite, infinite. All right. It will never expire. These can expire, and when they do, the system will effectively ask for the capability of keeping the same one. And when it asks for it, what I really mean is it does a DAD test to validate that that's still a good address to have. All right, that's all it really wants to know, is that, is this a good address? And it's really fun to kind of watch traffic, watch things occur when that preferred lifetime expires and you actually get another address. See, at that point, it completely renewed. So at that stage of game, these addresses will keep on going for a long time. And so even now on this system, if I want to go out and do things, life is good. All right, life is really good. I can go to Google, look at IPv4 V6. All right, I go to Facebook, I can get there, IPv6. Now, I want you to just look at something. Did you notice when I did an IP config, look at its v4 address. It's the APIPA address. It's not routable. It's not static. It's not a DHCP address. It's got no v4. What's going to happen? Let's go to Twitter. One, I can't spell it. First off, Jeff's got to spell it right. All right, I can't get there. This is a V6 only system. So anything that's on V4, I can't get to from here on that computer. I don't have a NAT64 DNS64 running here. So, oh my goodness, this is what's going to happen if you try to go V6 only. You kind of can't yet. Now, you may say, Jeff, I don't do Twitter. No problem. All right. You may be able to go to other places. 4 to 6 labs. All right. 4 to 6 labs I can because they are dual stacked and I'm getting there through V6. But if you remember when I went to 4 to 6 labs earlier, there was also on my own system, there was that other address. But right now, all I can do is V6 work. So this is a kind of a couple of fold example. One, I'm going through a tunnel provider for my V6 work, and I'm like 2 levels down from my internet point of presence. And 2, if you want to go V6 only and you don't have a NAT64 DNS64 to use, whether you build it or you use one of the publicly available ones, this is going to be your V6 experience. All right. Some things you may not get to. Now that may be okay. It may not be okay, but I just wanted to kind of show that as an operation. I'm going to drop that connection for right now. And if we would have gone through in some of this, we probably would have seen, I just clicked on my RDP filter just to kind of show you that I was doing that RDP session to that device. So you might remember I was going to C3A. So there's all that RDP traffic that had been building up in my trace file here. If you look down here too, it's very interesting that I've got over 350,000 packets so far in my live trace, but only 5% of them are V6. So yeah, even though I'm in a V6 world, there's a lot of stuff that I might be accessing that's still not V6. But that's okay. I am happy that I'm just doing it. That's my key. Let's do another RDP to a fully enabled system. That will be this guy right here. This particular system is sitting on my internet provider side of the network, okay, not on, oh, it looks like it rebooted. I had stuff up and running. Don't know why that happened. Oh, we got to do this. So I want to show you what that address looks like. There it is. And we can see an interesting operation here. All right, V6, public address, V4, public address. All right, there's my link local. All right, 5th and 6th hextets are not FFFE between them. All right, so that is the random number generator. We see this temporary address. We see this V6 static address using the same last 64 bits. Last 64 bits as the link local. But look, I've also got a DHCP address. I've got 4 valid V6 addresses on this interface, 3 of which are in the same network, all right, but 3 different host IDs. You can't do this in V4. You can't have the same network, 192.168.2.1.2.3 on a typical client operating system. Server maybe, network operating system maybe, but on typical clients, not in the same network prefix. So in this case, the question becomes, which of these 3 addresses is this system going to use? Well, the generic default answer is it's supposed to use the temporary address. That's the definition in the RFCs for off-link communications. It should use its link local for on-link communications. It doesn't mean it will, and doesn't mean it can't. And it doesn't mean you can't access this system through one of these other addresses. Look, I RDP'd to the 49 address. All right. I didn't RDP to the temporary. I didn't RDP to the fixed V6 dynamic address. I went to its DHCP address. So while there are rules, there are sometimes different ways of getting, I won't say getting around, that's not the right way, different ways of still using your environment, let's say to what you would like to be. Joseph, I forgot. Am I at the cutoff point? Did I go past my time?
So you still have a little time.
Okay, I'll wrap up the next little thing I wanted. Thank you. So yeah, I've been trying to show varying things as we go through here, these different OSs and how they're reacting. You know, we saw on that other client, he didn't have a DHCP address. He only had the addresses via the other Slack, and it was a V6 only world, where this is, you know, here a dual stack world. If we fire up Wireshark and kind of look at what's going on this particular client, a little bit different, but similar stuff, right? That he's got out here on his network. And I think I am running on network 8. So we'll let this thing fire up. And let's go to V6 only, just because I like V6. All right, and make that a little bit bigger. And I'm also going to filter out my RDP traffic here. I'm going to IPv6, but not any of the RDP. So you can kind of see just what's going on that client, right? There's a little bit of V6 work happening here. And, oh, I didn't want that browser, but that'll work nonetheless. You know, we can go to Google and we could come back up here and we could do this. Let's look at DNS only traffic. All right, and we can kind of see in here some V4 and some V6, you know, looking DNS traffic. One of the things that we potentially could see in here with the V4, and it's kind of interesting. If we look at V4, we see what looks to be a request and reply. If we open this up, we can find out, well, what kind of question did it ask? And in this case, oh, that's not the flag I wanted. What was the question? The question was for an AREC, okay? If we look at the V6, look at the V6. It asked for an AREC query or a request and a quad A. And so the system's going to act on whatever it can. And here it's going to end up getting its replies. And this is the great part. He gets the V4 replies. Now, the OS, it's coming back on the V6 protocol. It basically says, okay, fine, you know, store it in my DNS, not repository, my DNS cache. All right. Whatever answers I get, it came in through V6, it came back as a V4. Okay, store it. All right, and I'll use it however I can. So kind of an interesting overall point of how this protocol works, and if you're going to go dual stack, some of the operations of that environment. Okay, one more I want to do here for you. Actually, I have 2 more things I want to show. I'm going to liken to RDP, but I'm going to do it over here to a Raspberry Pi that I've got up and running. And this particular Pi is the one going to my Unleash tunnel provider. And somewhere around here, I want to show you the addresses that I have here. All right, we need to pick up a few things. He's got his link local address. He's got a single global unicast route capable address. Look at his V4 address. This is a V6 only client. All right, V6 only client, but there's a difference. I want to show you my session. Here's the session, the VNC session that I've got up and running. Oh, here's me, that here, going to this guy. All right. If I ping somebody, google.com, I expect I'm going to go to their V6 world because it's a V6 system. No problem. All right. If I ping Twitter, okay. Who wants to bet money? No, we don't bet money. Who thinks this will work? Anybody think this will work? And now he pings. Wait a minute, Jeff. You went to Twitter a while ago on the browsers and only on that V6 client, that Star Wars client, and you didn't get anywhere. But you're on V6 only now. How is this working? It's working because English puts in a NAT64 DNS64 operation. So even though I'm V6 only, through their kindness on their system, I can get to anything V4. All right, and I'm actually going to an address that's still looking V6, but their NAT64 DNS64 is taking care of mapping that for me so that the V6 access works and the V4 also works. Here is the English page. They've got a couple of little devices that you can to buy. You can also just build a static or a tunnel through an application. So a nice other resource to get V6 operation. They provide V6 Colo. I've got a VPS over there as well. So they've got all kinds of nice little things. If we go to Twitter, even though I've already got the page here, oh wait, look, let's refresh that screen. I'm going to Twitter. I'm on a V6 only client. Woohoo! This is how we do it. NAT64 DNS64 provides a V6 only environment to still get to the real world everything, regardless. And look, even IPv6 says, yeah, you're going to V6. If you back out these addresses, you'll find out that this is Unglish's prefix. Again, they're NAT64 DNS64 is giving me this capability. So we've had a couple of dual stacked systems. We've had a V6 only that can't get to anything V4, and now this is a V6 only that can get to anything on the public net, on the public internet, because of a NAT64 DNS64 effective transition technology. One other thing for the network folks that I wanted to show is I've got a TFTP server running, all right, a little TFTP D64 now, not 32. And one of the things that I wanted to show is just a traditional, well, what are some of the things that we do in a networking world is I want to copy the running config over to this guy just to say I did, just to say I can, because it's fun and it's mine and I like to do those things. And we're going to call it 3810 new.config. And if I've got my syntax right, you can see over here it downloaded. And if I were to open up the folder where that config lives, here it is, 3810 config new, and there's that configuration file. So part of my goal was to show these varying applications of network and accessibility on different V6 platforms and show these for what they are and how they work. Now let's even do a TFTP, and it's going to filter it, and all my TFTP traffic was right there at the very end. So it's going to be at the very end of this trace. It's up to 750,000 packets, and there's that TFTP. All right. Now they do live in the same network space, but it really doesn't matter. It's still V6 is V6. With that team, I probably am out of time, but there's a little bit about V6. If you've not played with it, I encourage you.
No, you still have 2 hours to go. No, I'm just kidding.
Wait just a minute. I could feel no. I think we're probably done. It's been a while now.
Yeah, no, that was awesome. Thank you very much. I'm definitely going to set up. I'm going to definitely get a block from Hurricane and start scanning networks.
Yeah, but none of the ones you've seen tonight, right?
No, none of those.
None of those.
Yeah.
Well,
no,
I haven't seen any questions come through anywhere, so
yeah,
I guess everybody's either so experienced that it was just a refresher, or it was so new you're going, oh my goodness. But play with it.
Do you have a
Start
list
working
of like security tools, hacking tools, or other tools that can be used?
Well, at least the only few that I've played with like Nmap supports V6 and has for a number of years. There is a number, actually a couple of other ones. One of them's called the Hacker's Choice. I'm going to have to find the URL here. Called the Hacker's Choice. And I'll put this down in chat. And this is one of those that the individual wrote it for themselves because they wanted to learn about V6 and they wanted some tools. And so they wrote this. And so these are really, really handy. And there's another one, the SI6 toolkit. And same thing. This was written for self-learning and playing, and the author here actually has a more of a security kind of focus. Both of these tools are also included in Kali Linux and have been for about 4 maybe years, 5 years. So you don't even necessarily have to, quote, go get them. These allow more detailed, I would call it bit level tweaking in crafting packets to send on a network than say maybe Nmap. Nmap's a little bit more for scanning. I mean, you could do certainly a lot with it. But these tools, boy, they allow you to get in really, really, really deep. I'll go ahead and give a plug for another presentation demo that I have is basically exploiting your V4 network with IPv6. And that particular demo, I go into a publicly accessible V4 connected only network. And I find an exploited system or an exploitable system. I drop onto it. I find out that V6 is not in their protocol stack. And I light up V6 and all kinds of other devices start lighting up on the V6 protocol. And I'll sit there and do a bunch of recon on V6. And I use these varying tools. I'll use Nmap. I'll use the Hacker's Choice. I'll use the SI6 toolkit. And part of the interesting bit about this, the red team just love it because if an entity is not running V6, they're probably not watching V6. So therefore, I quite often can jump in there. If you lit up an Nmap scan on a, let's just call it business network, their chances of that being seen are greater, right? That's being watched for those kinds of operations. But it's being watched on V4. If it's not being watched on V6 because we're not running V6, then guess what happens? Nobody knows you're there. So this particular demo, I'll give away a little bit more. I'm wanting to set up an IDS, and I want to do an Nmap for V4, watch the IDS, alert, and then I want to do an Nmap on V6, and I want to watch the IDS not do anything. And it's kind of my red team showing what the blue team's not seeing, and then turn on V6 on the IDS, and then watch an Nmap scan get noticed. So that's a little bit of a tweak of an existing demo I've been doing for years, and hope to be doing that in a month or so. Possibly be doing it at SharkFest Europe in June, their online SharkFest.
Cool.
And possibly somewhere else. Maybe we talk in the Red Team Villages activities.
Yeah, we talked about that. We definitely would love to host a Red Team IPv6 talk.
So yeah, those tools are a lot of fun, and they're probably, I know there's a few other ones. One called Chiron. I typically mispronounce his tool. This tool came out a couple of years ago. Let's do it this way. I think I'm spelling it right. There it is. And I have not played near as much with his tool, but it is another one in caliber with the Hacker's Choice toolkit and the SI6 toolkit.
And what does his tool do?
I'm sorry?
What does this tool do? do?
It's same kinds of things. Basically, you can do all kinds of things where you can do attacks, you can do scans. So hybrids of the other tools.
Okay. Does anybody have any questions that they want to ask Jeff? You can come off of mute. Just click the little microphone next to your name and come off of mute and ask away. Otherwise, in less than 60 seconds, we're going to end this.
Well, thanks everybody. As you might be
I do have a quick question.
Oh, sorry, too late. No, go ahead.
So, my name is Arturo Garcia. I just had a quick question around how IPv4 and IPv6 maybe could work together. Is there any way to derive IPv6 from IPv4 and no kind of scanning something?
Nope, they are separate protocols. When you run them in an infrastructure, all of your routing protocols are separate.
Yep.
Your operation, they're basically what we call ships in the night, right? They're right next to each other, except for like that NAT64 DNS64, but they're not actually still writing together. There's a little bit of translation going on. But there was in the early standard in the V6. Sorry, let me throw this in real quick. There was an early definition in the standard to be able to embed a usable V4 address into a V6 and it to be stripped out. But they deprecated that a long time ago. Right. So it doesn't work, and nothing will work with it, at least from the infrastructure type viewpoint. So somebody else was commenting. I'm sorry. Go ahead.
Yeah, I was just going to mention that on routers. And I know only specifically on Cisco routers that there are tools to do IPv4 to IPv6 gateways, but yeah, you can't. They won't run together. You basically are doing a conversion and bringing things in. It's almost like NAT on a firewall where you're just NATing them to different addresses going in and out. So, like Jeff mentioned, they basically are completely separate. Kind of think of it like OSPF and EIGRP. They can ride on the same network and not see each other.
Exactly, and yes, there are some of those even from third parties that you go in one and it'll convert it. Not quite the exact same as NAT64 DNS64, but similar. But all of those are considered one, transition technologies, and two, not every OS would have them. Not every networking vendor would have them. Not every client OS. So while they may live out there, we kind of really don't want to go that way if we don't have to. But it's not the end of the world to do it. If that may be the only way, some of our carriers are doing that. And in order to provide, cell phone providers are doing that. You're doing V6 on your phone on the cell side of it, and they're converting it to V4 on the back end.
Makes sense. So really the only way is just if you wanted to get any kind of information about IPv6, you'd have to either pop the box and then figure out any kind of configurations on the machine.
Exactly. Yeah, okay. Exactly. That's pretty much it.
Thank you.
Yeah, anybody else have any questions? All right. We're gonna, what? Somebody say something?
Yeah, sorry. Hi, my name is Saad. I just want to have a question. You said something about when jumping in a network that doesn't have IPv6 support, and then you turn it on, then you can say stay indetectable in the network. But does not that affect the network bandwidth and in terms of consumption? Does that?
Well, I would say generically not, because your client or your applications, they're only going to use one protocol to do their job. So if I'm going out like we saw here, even to this site, it's only going V4. GitHub is one of those issues we have right now. If I go to instead google.com, I'm going V6. I'm not going with both my protocols to that site. I'm only going to use one or the other. So my protocol or my bandwidth utilization doesn't change from the application's use. Now, you might get a minor increase if your DNS is external, all right? But DNS traffic unto itself is very, very small. So it shouldn't be an appreciable increase in traffic. The other factor that's actually coming into play now is that it seems that most V6 traffic is now faster than V4. So even if you're starting to see, quote, more V6 traffic than V4, you might also see some applications operations being quicker in how they render or respond. But yeah, generically, you won't see double traffic just because you're running double protocol, except for things like DNS, except for external routing protocols. Yes, there are both of those, but routing protocol traffic unto itself is also very small, right? So it's not a huge increase as far as bandwidth utilization, other than maybe just an increase in packets, number of packets.
Right, and if it's not being used to talk to anything, it's generally just going to be local, traffic, and not much more than just a few packets.
Yep.
Okay, thank you.
That help, Said?
Hey, Jeff, there was a question because I'm been monitoring both YouTube and Twitch, and there was a question in YouTube specifically about the pcaps that you're sharing. Is there a GitHub repository or any place that people can download it?
How much money do you have?
Me, like 5 cents. But
Give me just a moment, and I will show a link. The content in that link may be a little older, but the trace file is basically the same. So bear with me. I do have something out on GitHub, so let me find it. It take me about 1 minute. There's what I wanted. Recap. Nope. It's like any other time, right? You can find anything you want in seconds until the time you actually need it. And then it's like, where did it go? Here's the one I wanted. Okay, here's the link. I'll put this in the chat, in our WebEx chat here.
yeah, and I'll also paste it in the chat in
Okay.
YouTube as well and Twitch.
Thank you very much. Appreciate that.
Absolutely. Thank you.
So yeah, all the standard warranties apply. There is no warranty, cart DM and all those kind of things.
Yeah, if you get infected or you end up getting run over by a semi truck, it's your own.
Yeah, or the snow and ice hit. Yeah, it should be okay. It should be okay. And there's plenty out there. Oh, you know what? There's another site. Let me show you. There's another site that a friend of mine has at Cellstream that he has a lot of traces that people can download just generically. And he also has a lot of display filters. And I've published stuff up on his site, cellstream.com. Cellstream, that he has a lot.
Okay.
Yeah, another awesome place for tool, not tool, but
Cellstream,
just a lot of information. Yeah, just a lot. And Andy's up at this part of the woods as well, and he's got a lot of fun stuff. If you go into like the profiles repository is just awesome. There's people from all over the world that are contributing to different profile configurations. Like my profile for V6 work, he's published some, others have put some up there, all kinds of other ones. So just a lot of fun, a lot of great information.
There's your name right there in the middle.
Is
800 downloads.
Oh, wow.
Anything else, Omar? Anybody else have questions?
No, I think that was a question. You're getting a lot of kudos and thank you from folks. Actually, so I take that back. There was one thing. If you hit a scan on IPv6, there will be some bandwidth, but more processor utilization on the switches. I guess that was a comment, not so much of a question.
Yeah, but it's not gonna create it's not doubling the traffic that's on your network.
Yep.
If IPv6 is not in use, it's just going to do the regular broadcast, looking for a router, looking for a gateway type stuff.
Exactly. And that's what makes it even more interesting. If you actually put a router on there and all those devices light up, they'll try to use that router for traffic. It may or may
Right.
not go anywhere, but they will still use it. And a forward-thinking red team exercise would be to not only put it on there, but to also make sure it's connected to that V4 network so it can get to the outside world. And now you're grabbing all their traffic. Their
Yeah,
V4
man in the
traffic
middle.
through their router will actually decrease. The V4 from the rogue router will increase, but it won't increase above what it was already being seen. So the still net bandwidth going outbound is the same. It's just where's it coming from? The company router, the IT router, or the rogue router.
And another question about the links. I think that you shared some IPv6 tunnel providers earlier.
Yes.
Um,
Yes, we did. We've got the tunnel provider or tunnel broker. They're probably one of the most common ones out there. Unleash is another one. They've got some really nice, a couple of products. I've got one, it's like literally a 1 inch square. And then they've got a little bit bigger one here. I'll put this down in chat as well. They've got a little bit bigger switch. They've got a Wi-Fi. They've got a wire, is that wire something?
Wire.
Oh, it's a wire guard. So you can actually run a tunnel from just a computer, whether it be Windows or Linux. I do that when I'm out, when I used to be out presenting, on sites. I used a WireGuard tunnel from my local computer to get to Unleash's environment. So a couple of options in doing that, as well. So Tunnel Broker through Hurricane Electric and Unleash has some really nice. Now the Unleash bit, you buy the product and you basically pay a subscription for their tunnel, whereas the Tunnel Broker is free. Tunnel Broker, though, you have to have an IP address that can be pinged for the tunnel to just build. It only has to ping once, literally one ping only. But Unleash, you can have anything you want. You don't have to have a dedicated V4 address for it to work.
Cool.
Awesome. And I thank you for the links. I also pasted the link for Tunnel Broker in both in YouTube and Twitch. So if you're following us there, feel free. And I think that's it. That's all the questions that I see from both sides.
All right, awesome. Thank you. So I think we're going to wrap it up. I think we're going to wrap things up. Thank you, Jeff.
Well, thanks everybody again for letting me come in. Well, just thank you so much. I love talking about this, and hope everybody had a good time. We'll pick up a few tidbits here and there, and look forward to talking again for you.
Awesome. Thank you. Well, have a great evening. See everybody. Next week, we're going to run another event, another speaker and another training on the 25th. So stay tuned. And then after that, we have somebody else. So we're going to be doing them all this month and all next month every week on Thursday. So thanks a lot.
And Joseph, I just got pinged on Discord as well. Is the presentation for next week already like in Meetup or any place?
No, I'm going to put it in tomorrow.
Okay, perfect. And we'll send this to all the different channels. So look into our Discord channel and also at all the feeds. All the different Twitter accounts that we have. From Texas Cyber, from the Red Team Village, and so on.
Red Team Village, Gray Hat. Yeah, check those all out. And DC 210.
Yep.
All right. Well, thanks everybody for joining. Have a good evening.
Thank you.
Thank you.
Thanks, everybody.